In the first part of section 3.3, we talked about differentiation rules and the product rule. In this section, we will talk about the quotient rule. So if we take the derivative of f of x over g of x, that equals to the denominator g of x times the derivative of the numerator f prime of x minus the numerator f of x times the derivative of the denominator g prime of x divided by g of x squared. Okay, in simpler terms, it'll be g f prime minus fg prime divided by g squared to get the derivative of f over g. All right, let's take a look at some examples. We have our f of x is equal to radical x minus 6 over radical x plus 6. Notice that we have a quotient of two different functions. Okay, we have a quotient. So because we have a quotient, we're going to apply the quotient rule. Now, we're going to say, instead of f and g, because I have an f of x, I'm going to use a and b, but the formula is still going to be the same. So I'm going to say a is the numerator, radical x minus 6, and b is the denominator, radical x plus 6. So according to the product rule, the quotient rule, we have b times a prime, so the denominator times the derivative of the numerator. That's the same thing as saying g times f prime, right? In this case, our denominator is b, numerator is a, so we have b times a prime minus a times b prime divided by b squared. So let's, on the side, write down all the things we need. We need a, we need b, we need a prime, and we need b prime. So let's write all those down. A is radical x minus 6. I'm going to rewrite that as x to the 1/2 minus 6 to take its derivative. And a prime, so the 1/2 comes down. So I have 1/2 x to the negative 1/2. Remember, we have to write this using positive exponents and in radical form. So the x to the negative 1/2 moves to the denominator. We have 1 over 2x to the 1/2. And x to the 1/2 in radical form is going to be 2 radical x. That's my a and a prime. Now, similarly, let's do b and b prime. My b is radical x plus 6. So I rewrite that as x to the 1/2 plus 6. And if I take the derivative of that, once again, the 1/2 comes down. So I have 1/2 x to the negative 1/2. Negative x to the negative 1/2 goes down again. That gives us 1 over 2x to the 1/2, which is 1 over 2 radical x. So we get the exact same derivative for a prime and b prime because the constant 6, 6 or negative 6 doesn't matter since the derivative of a constant is 0 anyway. All right, so let's plug this in. I have b, which is radical x plus 6 times a prime, which is 1 over 2 radical x, minus a, which is radical x minus 6 times b prime, which is 1 over 2 radical x. And that's all going to be divided by radical x plus 6 to the second power. Now, if you simplify this, we do have to distribute. So if I distribute the 1 over 2 radical x to the radical x, what's going to happen is we're going to get the radical x is going to multiply with the numerator. So we have radical x over 2 radical x. The 6 distributes, so again, 6 multiplies with the numerator. So we have 6 over 2 radical x. Same thing over here. You have a negative, and then you have radical x times 1 over 2 radical x. The radical x multiplies with the numerator, so that's radical x over 2 radical x. Then we have the, so now here we got to be careful. We have a negative 6, which actually makes a positive 6. And that distributes to the 1 over 2 radical x, so we get 6 over 2 radical x. All that divided by radical x plus 6 to the second power. If we simplify this a little bit more, the radical x's cross out, so we have 3 over radical x. 6 divided by 2 just gives you a 3, so we have 3 over radical x. And then here, the radical x over radical x, those cross out. And what that does is you got one positive radical x over 2 radical x. You have one negative radical x over 2 radical x. So those just cancel each other out, right? And then here we have 6 over 2, which is 3 over radical x. Here we have 6 over 2, which is 3 radical x. Now if we add these together, this is going to give you 6 over radical x divided by radical x plus 6 to the second power. So once again, these two crossed out because they were the same term but different signs. And then you have 6 over 2 is 3, 6 over 2 is 3. At the numerators, we get 6 over radical x. So that'll be our derivative. Now to find f prime of 3, we simply plug in 3. So I have 6 over radical 3 divided by radical 3 plus 6 to the second power. Put this in decimals.com and you get 0.0579 as the answer. So take a look at all of it, take a look at the derivatives, take a look at the algebra of it, and come to class with any questions that you may have. Okay, next we have 7x squared plus 7x plus 2 over radical x. So once again, we have the quotient rule because we are dividing two different functions. However, we are going to have an exception to this. The quotient rule, as you saw, can be pretty complicated. So anytime this happens where we are dividing by a monomial, we can actually split these up into three separate terms. 7x squared over x to the 1/2 plus 7x over x to the 1/2 plus 2 over x to the 1/2. Remember the quotient rule of exponents, where if you divide the same base, we subtract the exponent. So we subtract 2 minus 1/2, 1 minus 1/2, and then this just moves to the top, becomes x to the negative 1/2. So 2 is like 2 over 1. So this becomes 4 over 2 to get a common denominator. This is like 1 over 1 becomes 2 over 2 to get a common denominator. And if I simplify that, I get 7x to the 3/2 plus 7x to the 1/2 plus 2x to the negative 1/2. Okay, so that's you can only do this though when you divide by a monomial. If you don't divide by a monomial, this does not work. And now I can take the derivative of this whole thing, which is a lot easier in my opinion. So the 3/2 comes down. We have our standard rules of taking derivatives, subtract 1 from the exponent. Here the 1/2 comes down, subtract 1 from the exponents. Here the negative 1/2 comes down, subtract 1 from the exponent. So if I simplify this, I get 21 over 2x to the 1/2 plus 7 over 2x to the negative 1/2 and then minus x to the negative 3/2 when you subtract all the fractions by getting a common denominator. We have to clean this up because we can't have any negative exponents, so those have to move to the denominator and convert those into radical form as we've been doing. Remember, for x to the 3/2, it'll be radical x to the third power because of the numerator of the exponent. And then to find f prime of 2, we just plug it into Desmos, replace all the x's with 2, and we're going to get 16.9706 as the answer. All right, let's have f of x equals to x over x plus 7. Now this time we want to do something a little bit different. We want to find the values of x where f prime of x is equal to 6. So first let's find f prime of x. That'll be b times a prime minus a times b prime over b squared. So let's list our a prime, b prime. This time is a lot easier. A is the numerator, which is x. B is the denominator, which is x plus 7. A prime is 1, b prime is 1. Because the derivative of x is just 1, the derivative of x is 1, and the 7 derivative of that is going to be 0. So f prime of x is going to be b, which is x plus 7 times a prime, which is 1, minus a, which is x times b prime, which is also 1, and divided by x plus 7 to the second power. I'm going to distribute this 1, so that's going to give me x plus 7 minus x. The x minus x is going to be 0. So this gives me 7 over x plus 7 to the second power. That's my f prime of x. But the question doesn't say find f prime of x. We want to know, where does f prime of x equal to 6? So since this is f prime of x, we're going to set that equal to 6. Remember the basics of solving equations? We don't want a denominator, so we're going to multiply both sides by x plus 7 squared. So we move the x plus 7 squared to the other side. So we get 6 times x plus 7 squared equals to 7. Now we want to isolate the variables. So we're going to divide both sides by 6. So we kind of just flip-flop the x plus 7 squared and the 6. So the x plus 7 squared can go on the numerator. The 6 comes to the denominator. To get rid of that square, we're going to square root both sides. So we get x plus 7 equals to plus or minus radical 7 over 6. And then subtract 7 from both sides. And our answer is going to be negative 7 plus or minus radical 7 over 6. Okay, so take a look at this. If you have any questions on the calculus part, on the algebra part, just come prepared to class with some questions. Next, S of t is equal to 4t squared cubed plus 30t squared plus 48t. And we want to find the function for the velocity. So I'm going to give you guys like 3 different levels of a position function. So S of t is going to be the position of anything that's moving. So the velocity or the speed is going to be S prime of t. So the velocity is how fast is this particle moving. Velocity is the speed of this particle. And if you take the second derivative of S of t, or the first derivative of S prime of t, this gives you the acceleration. So acceleration is like you might be going 50 miles an hour, but at that time, are you slowing down or are you speeding up? That'll be the acceleration. So to find the velocity, we take the first derivative. So you multiply 3 times 4 is 12t squared, 2 times 3 is 60t plus 48. Where does that equal to 0? So we set it equal to 0, and notice that they all have a common factor of 12, so we're going to factor that out. So when you factor it out, you're dividing both sides by 12. So we get 0 equals to t squared plus 5t plus 4. Now we can factor this or use a quadratic formula, but factoring is easier. We have to find 2 numbers that multiply to 4 add up to 5. Those are going to be 4 and 1. And so for our t values, we get negative 4 and negative 1. Now this doesn't make sense because the velocity equals to 0 at negative time, but we're going to go with this for now. The acceleration is the second derivative of the position function, or the first derivative of the velocity function. So we have our velocity. So if I take the first derivative of that, that'll be 24t plus 60, and that's going to give us the acceleration. And let me get rid of this. So our acceleration is going to be 24t plus 60. So this did not involve the quotient rule, as we can see. All right, last we have fg prime of negative 3. So when you multiply 2 functions, we're going to apply the product rule. And the product rule for fg prime is going to be f of negative 3 times g prime of negative 3 plus g of negative 3 times f prime of negative 3. So remember the derivative of a product, the derivative of fg is just equal to f times g prime plus g times f prime. But because we have it of negative 3, we have f of negative 3, g prime of negative 3, so on and so forth. Now if you find these values, so here's negative 3. So if I find f of negative 3, its value is 7, negative 7. If I find g prime of negative 3, so this is g prime of x of negative 3, that's value is going to be 5. So we're basically going to plug in these values. G of negative 3 here is just negative 3, and f prime of negative 3 is negative 1. So in this column of x equal to negative 3, we have all these values which we plug in. And that'll give us 38 as the answer. Now the second one is the quotient rule. So if you have f divided by g prime, that'll be f prime times g minus g prime times f. And again, we're doing this all for negative 3. So f prime of negative 3, we have all the values here. That's equal to negative 1. G of negative 3 is going to be negative 3. And then you plug in the other values, you simplify it, and we get negative 32 over 9 as our answer. Okay, once again, make sure these notes are copied down, and any questions you have, I'll be more than happy to go over during class. Thank you guys and see you soon.